So in this video, we're going to have a look at how we know if our decision tree is good. So we've used the computer to create a decision tree for us. How do we know it's going to be good? Is it sensible to use this one? Is it going to give us good results? So we do this with something called the cross-validation score. And this does a technique called K-fold. So it splits your data into K number of sections. So let's go with 3 because that's a nice easy number to work with. It splits your data into 3 sections. One of these sections it takes away and it moves it over there. It doesn't have anything to do with it. So these sections are taken at random, so it's a representation of the data. These other two, these 2/3 that are left, you train your model on this. You create your model, you train it, you get your answers. And then you bring this third back. So this is your testing data. So we know that this data originally was all together. So we know the answers as the start for this data set, and we know it's the same type of data. So we run our model on this third of the data that was hidden away, this test data, and that allows us to look at how good our model is. Because we know what the answers are, because they're included in there. We know it's the same type of data because we've taken it away from it. And you do that several times. So you randomly select a third of your data set, take it away, train, test on it, put it back in, a new third take away, train on this, test on the bit that's taken away, and so on. So you get 3 values for how good your data set is. And actually now the standard's gone up to 5, so you do K-fold and 5, split it into fifths and take a fifth off. But a third works slightly better visually. And this is just showing you the idea that I was talking about. We've got our data set split up, and remember this is random splits. It takes that third away, we train on 2/3 of it and test on that what's left. A different set and a different set, and then we can take an average of these results because we know the answers. So say we get 90% of our answers correct when we run our model on this testing data, we know our model's 90% accurate. That would be very good. It's normally slightly lower percentages than that. And then if we do this 3 times, you're getting a more accurate answer because you've averaged 3 different sets of data. Okay, so that's a train test split done by the cross-validation score. And this is just a very simple way of working out how good your decision tree is that you've created to actually get your decision. Right. So the next video we're going to have a look at advantages and disadvantages of decision trees because it can't all be perfectly rosy. They are excellent, but there are some downsides as well. I'll see you there when you're ready.